Right. Let me just check if the live stream is up. And right, we'll start. Okay. So an update from yesterday. I said I'll finish up what I did, and I did. So I think I put it on the timer on, but it did take about 2 hours from there. But I do have some code, and it does work. I think I've set up the audio capture right. So if I play it, you should be able to hear it. So I'm just gonna run this code. As you say, it's run and it's formed a file. We'll go there. There should be a file here called output, which it is. I'll click this, it'll open here. That's what I've made. As you can see, there's a chord that plays I'll briefly describe what I've done. So I made an array of the C and E blues scale. And so basically each number represents a note, and there's a two-dimensional array where each row of the array contains a chord. So I think I forgot the name of these chords, but I'll mention it when I sort of wrap things up. Then there's a function which plays music, and for what I pass through the chords, and for every chord I play four notes, so which you can go, which if I replay it, you'll understand. Right? And yeah, so basically these are, and I randomly, so the randomness, it's not all coded. The randomness is that within the scale, the computer chooses which randomly chooses which notes to play. And yeah, other than that, this is quite simple in that sense. So today's goal is going to be working on this forward. And what am I doing? Yeah. So today's goal is going to be, I think, first is going to be working on how do I set up a learning model so that a computer, if I give it some jazz pieces, because I think ragtime and jazz is sort of where this is going to work the most, given that it's slightly more method methodical than some other interpretations of music or genres of music. And yeah, so I think I'm going to set that one up first, and then if I have time at the end, which I don't think I will, but if I do have time, I'm going to fix this up and try to make it more standardized for each uh, scale. Like instead of having to pick and choose each scale, I can get an input. Okay, I want user wants to play C blues, and then I, based on that, it there's an array of. Okay, I'll explain the logic later, but it seems pretty simple to me. So yeah, I'm gonna close OBS and I'm gonna start the timer for today. The timer for today, I'm gonna close this as well. Can you guys hear me? Of Okay, I'll explain the logic later, but it's working on this. Could you hear the randomness? Uh, okay, this goes here, this goes here. Cool. Let's start the timer for today, and yeah, let's get into it. Why is my computer running so slow? It's taking so much energy. OBS. Okay. Maybe it's other things wrong. Okay. Magenta is, this seems promising. What it to say? So, okay. Magenta is a Python library that helps you generate art and music. Okay. Going to install Magenta. Fine, fine, fine. Okay. Okay, this is quite simple. It's similar to what we did yesterday. But it's not storing in a MIDI file, it's storing in a note sequence file, which according to the documentation is a faster format. So fair enough. Uh, yeah, I mean, but this has velocity also, which is interesting. Okay, melody RNN suits what is this? Music preview. I need to do. Oh, okay, no mind. I think melody RNN sort of what do you call it? Fits our needs for this project because I'll be feeding it some jazz music. Okay, so I don't think it's wise if I start getting into the maths of it right now. Maybe I can understand. I've understood what the basic structure is and why we're using this. Basically, we're using an LSTM as you read, an LS, a type of recursive. Is that what's called? RNN? Recurrent. Recurrent neural network, a type of recurrent neural network, which can, for our purposes, use both the current, like use previous information to detect the next one, where it's slightly correlated, which is essentially what piano pieces are like. Where if you know the previous notes, and even if you're a pianist, and you can sort of guess what the next one is going to be, given the chord progression and given the previous notes. So I understand that to a certain extent. So I'm just gonna read a little bit more about it before I double down with this and try to see if I can Okay, this seems fairly straightforward. What is this? Somebody already made a music generator. I mean, I could use this. Added code, music PNG. Here a demo of a result. Sure. This is the codes. Okay. Oh, it's the same thing. Can you guys hear it? I think you can. Yes, you can. Okay. That's pretty decent. But I think so. One idea is I can go through this code and sort of see where he is getting his ideas from. That's one idea. The other is
Hey, are you okay?
I want to make music, but I don't know how.
Talk about the bleeding edge in machine-generated music, then write our own music generation script in TensorFlow in just under 90 lines of Python. I'm a big next layer, but no two nodes of the same layer are linked. That's the restriction part. Each node decides whether to transmit any data it receives to the next layer or not by making a note that
oh man. I thought it was a scam.
are model layers serve as our gateway for inputting data into our model. Then a variable one.
Okay, he's just explaining the same code. He's not doing anything. Okay, so basically I think the way to do this, because we do have the code, so I'm going to start sort of, I think you have to reverse engineer it, because I mean the rest of it is like I obviously won't understand this. I need to first do it and then understand it. So what I'm gonna do first is install the dependencies and see. I think we have TensorFlow installed though, so it's like that should be okay. Um, Wait, no, what? Wait, one second. I swear, one second. I swear the guy in the previous video, yeah, is reading out this article.
Hey, are you okay?
I swear he said the exact same thing, like in verbatim.
The program would convert that speech to text, then for each word, it would find the associated vector. It would then compare those vectors to vectors created by a model. Released a paper a few days ago called WaveNet, which is now the state of the art in both music generation by putting a bunch of static fragments together. Ideally,
I don't know what he's talking about.
a waveform of the audio signal. Researchers don't really do that, but WaveNet did. For processing, then we encode it to produce a tensor then pandas as our data analytics library, then of course tabulation, which is our helper library. Let's start off with the first step, our hyperparameters or tuning knobs for our model. We're going to use a type of neural network called a restricted Boltzmann machine as our generative model. An RBM is a two-layer neural net. The first layer is visible and the next layer is hidden. Nodes within layers are connected to nodes in the next layer, but no two nodes of the same layer are linked. That's the restriction part. Each node decides whether to transmit any data it receives to the next layer or not by making a
Okay, I'm gonna read about this later, but why is it opening? Okay. What's an MSG pack Python? Okay, so I think I'm gonna get the MIDI files of all the jazz pieces. So how many pieces did they use? What is the training data? It was okay, that's a decent number of songs. How many is that? 88. Oh God. Okay. Uh, Jazz. Okay, I'm gonna try and find jazz songs MIDI. Okay. This seems like such a shady website. Oh my god. Uh, okay. Well, let's just listen to the most famous jazz music. I don't like this. There's a daily minute of 5 now, man. I've just realized I'm on mute. But yeah, at this point, I'm just handpicking the songs I like because I want the computer generated audio to be something that I like. But yeah, right now I'm just gonna put them in a folder. Um, oh, it's going here only. Oh, that's fine. I mean, not really, but okay. New folder. Okay, within which we'll have new folder. Uh, okay. Um, okay. That's nice. I think about 30 to 40 would be sort of the range for now.
Hey, Kelsey!
This is too slow. is this? A brain? How many do we have? Is that enough? How many is that? That's 19. Okay, let's do some more then. Oh, that's nice. Like that. What's that Hindu rag? What?
Eins, zwei, drei, vier. Hey, Kelsey.
Okay, that's it. You know what? I'm done. How many songs is there? Oh god, wait. Alright. How many are there? There are 32. Let me remove one of them. Sorry, you have to go. And you have to go. Okay. We have put 30 training songs. And. Hold on. Hold on. Okay. 30 training songs have been put. I shall see this link and put it in my this thing. Yeah, okay, cool. Now what to do? I have my training library. Let us look at the code. Because, okay. Uh, we have to. Okay. Now let us see what all we have to import. Okay, the live stream is still on. Okay. Now let us see what all we have to. Okay. So let's install the, wait, we've installed this, right? This is, wait 1 second, no, 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 no. I have to open. Wait, array, I have to install this thing for this. I have to install Spider for that, this thing. I have to close this and wait for Spider to install. Right? And yeah, so basically these are, and I randomly, so the randomness, it's not all coded. The randomness is that within the scale, the computer chooses, which randomly chooses which notes to play. And yeah, other than that, it's quite simple, simple in that sense. So today's goal is going to be working on this forward, and what am I doing? Yeah. So today's goal is going to be, I think, first is going to be working on how do I set up a learning model where the computer, if I give it some jazz pieces, so I think ragtime and jazz is sort of where this is going to work the most, given that it's slightly more methodical than some other interpretations of music or genres of music. And yeah, so I think I'm going to set that one up first, and then if I have time at the end, which I don't think I will, but if I do have time, I'm going to fix this up and try to make it more standardized for each scale. Like instead of having to pick and choose each scale, I can get an input. Okay, I want user wants to play C, blues, and then I, based on that, it is an array of. Okay, I'll explain the logic later, but I think it seems pretty simple. Some other interpretations of music or genres of music, and okay, Ira joined us there. That was fun. I'm installing Spider right now because you have to install like different stuff for. Is it done? Spider. Wait, what? Where did it go? Yeah. Okay. Cool. So now that Spider is installed, I'm just gonna quickly write these statements to check if everything is imported properly, and then one by one I'll go through the statement and understand what they mean and write them on my own. Because otherwise, what's the point? Get songs make sense. What is a glob? Glob Python like. Why does it keep on asking if I have a computer? Sorry, robot. Okay. What is a glob Python library? It is a useful part To return all file paths that match a specific pattern. Oh, that's easy. That's good. Sorry, not easy. That's good. What was that? I was reading here. Yeah, yeah. Okay, so this is get songs. You have a this thing file variable. Okay, so this is in